Good afternoon, everyone. So today we are doing about data handling model applications. If you see the picture, there are in the lab there are so many chocolates. So first, what we need to do is we need to organize which kind of chocolates we have. We have dairy milk, we have KitKat, we have Snickers. This helps to understand where in this lab we don't know how many chocolates are there. So it helps us to understand how many chocolates are there in the bag. You can see the chocolate. We can count the number of chocolates in the bag. See, we can see that we have 8 dairy milks and 5 KitKat and 3 5-star and 4 part. So this is what exactly what data handling is. Data handling is a process of collecting, organizing, representing, and interpreting data. So collection is a process of gathering raw data from surveys or observation, and collecting and organizing the collected data, like sorting data usually using tally marks or frequency tables, and representing that organized data in the form of graphs to display the information, and which helps us to interpret the reading and drawing conclusions from these graphs. We can represent this data in various forms. You can see the common representation type includes pictographs, bar graphs, and bar graph or chart, double bar graph, line graph, pie chart, histograms, and tally charts or tables, and also dot plots. We can see the we can see the pictograph which represent data using pictures or symbols, often used in early education to represent frequency. We can see there is a table. There are apple, pear, grapes, and banana. So how many of you like apple? How many of you like pear? And how many of you like grapes? How many of you like banana? Okay, each individual represent one goal. So if 8 persons like apple, we can show that with a emoji symbol like this. If 8 persons like apple, we can show that with a smiley face like that. These are called pictograms. The same data can be represented in form of bar graph or charts, which uses rectangular bars to compare different categories. There is another. We can also represent in form of double graph chart, which compares two sets of data simultaneously. You can see that image here. So this is the image of a bar graph. We can see here there are potatoes, onions, tomatoes, and capsicum. And in y-axis, we can see the weight of the vegetables in kgs. Here we can see the scale. See here one scale. 1 unit is equal to 2 kgs. I guess you can represent this potatoes present here 12 kg, here 16 kg like that. You can represent this data. This is the example for a double graph where there are 3 students A and B, C. If you take a student A, with subjects maths and English, you can represent the marks of a student by comparing the 2 subjects, that is maths and English. This is how you can compare the 2 subjects for a student using double bar graph. So there is another graph called line graph, which shows trends or changes over time using point connected by lines. Here you can see the points connected by a line, For example, in a week, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, the temperature can be shown for whole week with the example of this line graph. So, a pie chart is a circular data visualization tool divided into sectors that illustrate numerical proportions of a whole. So, this is the example for a pie chart. So, these pie charts, in this pie chart you can see the number of students who play football is 25%, cricket 17%, badminton 12%, hockey 5%, and other games like 41%. A histogram is a graphical representation used in statistics to show the frequency distribution of numerical data by grouping into continuous intervals or bins. You can see the histogram. This is the example for a histogram. A dot plot is a simple, effective data visualization tool that represents numerical data points as dots placed above a label number line. So this is a random dot plot of a random values. You can see this as an example. In the data management, data handling, in the process of data handling, you can also use statistics for the process of summarizing data by using mean, median, and mode. These statistics deal with the summarizing and analyzing data. And in the process of data handling, you can also use probability, which tells us the chance of an event happening with the formula probability of an event occurring equal to number of ways it can occur by total number of outcomes. With the help of data handling, we can calculate the traffic calculations that, for example, like estimating the likelihood of a traffic jam to decide on a common route, and to calculate the possibility of a political elections. If you take the politics and elections, pollster uses this data for handling, collecting the data, to use this as a probability to project the chance of a candidate winning or losing an election. So we have just seen the data handling. We have just known what is data handling. So we can see what is the data handling of modern applications of data handling. You can see now. So these modern applications of data handling we can use in the modern applications like weather reports. Like this weather reports, we can these weather reports use data from satellites and sensors, and these reports use the data, and it will predict the temperature and rainfall, and also storms that can occur. And this modern applications like social media, this social media tracks our likes, share and comments, and based on what we like, share and comment, it suggests content using the algorithm for the other people also. So let us try to understand this modern data handling in modern application with the help of Netflix, how this Netflix recommendation and how this Stranger Things is being recommended by so many people. So here we can see the in a home screen, we can see the Stranger Things is being shown, being recommended, and here it also shows the what is popular on Netflix, and how it shows this how it shows this popular on Netflix, and how it shows the Stranger Things, how it is recommended to you. You can try to understand. Here, what this Netflix or the social media platforms, what the modern applications do is, it collects data of us. Like first, let us try to understand what it does. Netflix collects data about user behavior, like what movies, series you watch, and how long you watch, and what you like, skip or search, and how much time you spend on which device you use it. So if you watch a lot of action movies, it will suggest action movies, and Netflix records this as a preference. So this is the what data collection is in modern application. And next thing is data storage. All this data is stored in a large database, and for each user has a personalized profile. So which helps. In this profile, your watch history is saved, and this watch history is saved for latest recommendations. And storage data is processed using AI and algorithms to analyze data and to find the pattern in your behavior and compare your case with other users and predict what you and they like. For example, if there are two users, A and B, and if users who watch A also like a movie B, and there are chances that Netflix suggests movie B to another user. So why this is important, because data handling helps Netflix to save users' time and increase user satisfaction and keep users engaged for a long time. So this is the process of data collection in modern applications. In almost all the modern applications, we can see this type of data processing. First, all the modern applications collects data, which is data collection, and this data is stored called data storage, and the process is called data processing, and which gives a certain output called data output. Thank you.